Welcome to this recording of the Social and Practical Astronomy meeting held at Planetary on Thursday the 16th of September. The meeting is called Messier Marathon in a Minute. Now, we're not aiming to cover every Messier object in a minute. For those of you know, there are 110 Messier objects in the catalogue, but we're going to try and explore the Messier catalogue using astrophotography with subs taken in less than a minute. So it's typically what you could see in the course of a couple of hours using a camera set up on a telescope and taking exposure typically of around 30 seconds of each object. And we're going to present to you what you can actually see from an exposure of that sort of length of time. We'll also take a look at some more high quality professional images taken, for example, by the Hubble Space Telescope, or indeed one or two images of really good quality taken by members of Nottingham Astronomical Society. So we'll also have a quick look about the Messier the man. Barrie is going to give us a talk on Charles Messier and his life. And once we've looked at each image of the Messier catalogue that we've taken, myself, Julian and James are going to tell you a little bit more about the physics of those particular objects. And we'll also take a look individually at the types of grouping of Messier objects contained within the catalogue. So that's planned for the meeting. We're going to start then first with Barrie, who's going to talk about Charles Messier.
Right, well this is Charles Messier at the age of 40. It's quite a famous picture, you see the view on the books. I don't know who painted it, but he's wearing a medal. He was awarded a medal, a Legion of Honour. It's the highest award possible for a civilian, and that was started by Napoleon Bonaparte. So it's interesting actually, Napoleon Bonaparte borrowed some telescopes to peer across from the French coast over to Britain to see what we were doing. So, right, next one please. Right, now Charles Messier was born in Bandon-Vier, Lorraine, France. I don't actually know exactly where that is. So basically he was always interested in astronomy, but he came to Paris age 21, where he got a job that was employed by Nicolas Delisle, who was the astronomer of the French Navy. And he introduced Messier to astronomy. I'm not sure if that's correct, because he was always quite interested anyway. Delisle had set up a small wooden observatory on the tower of Hotel de Clooney in 1748. I had been there recently, and there's no sign now the observatory was all dismantled. In late 1751, Charles Messier was employed as a copyist, and then as a basically general dog's body, depot clerk and observing assistant. And I think they were impressed by his methodical approach and how neat his handwriting was, and how studious it was. And then afterwards, under his direction, Messier looked for the expected Halley's Comet, and he couldn't find it because of Delisle's basically got the calculations wrong. It's a little bit disturbing because it says that he implied that everybody over the age of 70 might as well give up. So Charles Messier, he observed from that observatory for all of his life, basically. And I know it's in the middle of Paris now, it's hard to believe that you could see anything, but all that time ago, with no light pollution, it was fine. Next slide. Yes, this is the Hotel de Clooney, and the observatory is on top of that tower, so it's a wooden structure. It doesn't actually mention anywhere what this telescope's like. So, anyway. Next one. Yes, that's how it is now. Obviously, you can still see the tower that taken the observatory off. And the odd thing is that this place is actually advertised as a medieval museum, because that's where it was a museum before we started the observatory. If you go there now, there's absolutely no mention of Messier at all, which is a shame. Anyway, next one. Right. Yes, he eventually succeeded Delisle as astronomer of the Navy, positioning kept through the rest of his life. Messier's first documented observatory observation was that of the transit of Mercury on the 6th of May 1753, followed by various other observations since then. Yeah, it's specialised basically in hunting for comets. Wasn't interested in anything else, but he was sort of made a catalogue of things that weren't comets, which he probably found a nuisance. His most important work really was the compilation of his catalogue of nebulae and clusters of stars. The final published version contains 103 entries, but modern versions have been added to it, so I think there's about 110 entries. But he did have some help from Pierre Méchain, is it? Who collaborated with him as well. So. Okay, next one. Yes, this is this is from Wikipedia, but it's just his observations written from the observatory. I don't know if it was sequential order. It started in 1753. Next one. An example of the drawings that are in the catalogue. This one is the Orion Nebula. It's pretty good actually. It's what you see today.
Particularly the scopes at the time.
Oh yeah, that's when he was city. Yeah, it's not bad. Next one. Yes, this is a little plaque they put on in his hometown to honour his life. There's a few extra bits to it. He was a member of the Bureau of Longitude, and he's also a member of the Academy of Science in Paris, and also other academies throughout the world, or in Europe. Right, next one. Now this is Messier's grave. It's hard to find. I couldn't find it, but I don't know. I presume it's the.
It's this one here.
Is it? Yeah. Well, there's no markings at all, really. It's probably where it's hard to find.
I don't think it said much at all on it.
No.
Literally, I think it's a name and that's about it.
I probably thought they'd leave it nebulous for him.
I think on that note, I'll end it there.
When did you go to Paris then?
Oh, when did we talk? It must have been 4 years ago now.
Right.
So, I guess I sneaked off from the talk and did self-guided tour of the various places. But no, Paris is a big place and there are lots of cemeteries. So I think I would have needed to be guided to it. Anyway, right, thanks for that.
Thanks, Barrie. Great. Okay, so some of this actually Barrie's covered, so we can whiz through it really quickly. So the Messier, as Barrie said, did 3 catalogues. This was his very first one, which did, he listed the first 45 objects. It was actually quite difficult to track down a copy of the original catalogue. It took some searching. I think about the best we could come up with. So that was the original publication. There's some good translations of it actually online if you search for it and you want to have a look. It translates into English, so I can have a look at that if you want to. So it was, I think it was published 1774, but for some reason it seems to be a 3-year delay. There's 2 dates listed about. So I think it's actually written in 1771. I'm not quite sure, but there's something about that. There's a 3-year lag between dates, because that's why the dates don't seem to tally up on the Roman numeral side. So that's the first one he did with 45 objects in it. And it says that they're all from observations taken from Paris. So that was published in the Memoirs of the French Academy of Sciences. So he did a further 2 catalogues. This was the final one, the third one. So that was published in the Knowledge of the Times. I didn't know that is the oldest or longest running publication. It's quite interesting. And that had 103 objects in it. In fact, the third edition. And as Barrie said, there was 110 in total, which most people know. So they were added later and never put in the official catalogue. So Messier did his catalogue. Essentially, he was a comet hunter, and he wanted to catalogue all the objects that could be confused as comets. Essentially, that's why he developed his catalogue. Okay, right, plan for tonight. So that's essentially people have seen these posters that have got the grids, 110 in it to fill in all the objects. So what we did a week ago was, through that scope, C11, was try to image in less than a minute all the Messier objects that we could see. So they're the ones we're going to talk about tonight, so you'll be thankful we're not going to try and cover them all. That might just be a bit too much for everybody. So they're the ones that we're going to cover. Well, why didn't we image them all for Messier Marathon? Well, it's not the right time of year to see them all. You'd struggle probably anyway from this country, because obviously Messier observed from Paris, so some of the ones very low down in the southern sky, difficult to see. But yeah, the ones that we couldn't quite see. So the grey ones here, they were less than 15 degrees above the horizon, so a bit difficult to see in the work. M1, the Crab Nebula at the top, was behind the mountain, because it was from Wales. So that was visible, but not visible. So we're not going to cover any of those in grey, or the mountain. All of those, at the current time, are not visible at all, because they're below the horizon. I think the odd one or two of those might be visible at 4 in the morning, but that was too long to stay up. So didn't cover any of those reds because they're not visible now. So March time is the best when we're sort of pointed to see them back. If you want to try and see them all in one night, that's the time to try it, but quite difficult from the UK. Probably need to go down to Torquay to see them all. Then out of the others, those 2 we lost in cloud by the time we got round to trying to look at them. Can't cover those. And the ones in purple, we hadn't planned to do this meeting, so we just didn't do them. Otherwise we might have done. So that's the ones we're going to see shortly, are those. Probably can't see that very well, but that's just a view from Stellarium, showing, I think, was that taken? May time, is it? On the day, yeah, May time. So that's when we can see quite a lot of them are near that southern part of the sky, so the south's down there. So a lot of those haven't come up yet, and we can't see those at the moment. There's a couple of very, very difficult objects to see from the UK. Again, Messier observed in Paris, so Ptolemy's cluster there, that's very, very difficult. You've got about an hour to see that, I think, in May to see that. So yeah, March to April I've written down. You can see that one from the UK. This is from Torquay, so that's how low down it is, so even lower from Nottingham. And then the Spectre cluster, which is that one there. You can only see that really from the UK in the early evening in November. So if you wanted to see them all, you might have a job doing them. So that's just a quick look at those. Right, so the imaging setup that we had for this, so all these images you're going to see are exposure of less than a minute taken through the C11 telescope, and we've got a focal reducer on that as well. So it's a f10 focal ratio on that scope, focal length 2.8 metres. So with the focal reducer, it does shift that down by 37%. So the image scale, if we're looking at the full moon with this setup, the camera we're using is the D6 Canon camera on the end of that. That's the sort of view you'd get. So all the images, that's your sort of scale reference for tonight, essentially, on the full moon. So just to bring that slightly closer to the type of thing we're looking at tonight, Andromeda M31, that's the view that we'll get in the red box with that camera. We're missing quite a lot of the actual galaxy. So obviously for the small objects that we're looking at, that's better, but some of the bigger ones, we can't quite get them all in. Just to show the effects of the focal reducer, so that's the image that we took without the focal reducer on of the Dumbbell Nebula. With the focal reducer, that's what it changed down to, so you can see there's that slight change in the image scale with the reducer on. That just allows us to get more light into the scope in a short period of time with the focal reducer. So that's essentially why we put that on. Which, because we're not guiding the scope, is quite important. So it helps to allow us to get slightly longer subs without starting to split stars. Okay, so the Messier catalogue is classified into different object groups. So I'll just very quickly go through the different object groups that we're going to look at tonight. We're going to try and pick up one of each group. There's a couple we didn't image for these groups, so we can't cover those. So M1 is out on its own, there's only one in that group, the supernova and the Crab Nebula. M24, that's a star cloud, and there's only one in that category. Planetary Nebulas, there's a few more, 4 of those. Diffuse Nebula, quite a few of those. Well, that's Globular cluster, I think. Open clusters, double star, there's only one of those. We didn't image that. And group and asterism, one of those. Lenticular galaxies. Spiral galaxies, probably the most out of all of them. Elliptical galaxies, a few. And the regular galaxy, just one, which is the cigar galaxy. I thought it was quite interesting because there's no obvious pattern when they were catalogued in terms of the grouping, so they're all over the place, as you saw. So, right, so let's kick off. So the first one we're going to look at is we're going to do galaxies, and we have a galaxy expert. I'll hand you over to Julian. Right, what we'll do first is I've set the scope up to roughly point where the object that we're going to look at is located. So, because we're inside, so north is straight ahead, we've got south, east and west, so it's heading over there at the moment. Some of them we won't have to see because they won't come up yet. So the first one we're going to look at is over there. We'll put the image up and give the group the opportunity to show their knowledge and tell us what they're looking at. So anyone know what that is?
Good, very good. So M33, the Triangular Galaxy. This is one of the sort of 3 in our local neighbourhood of any significance. So we've got Milky Way, Andromeda, M33 comes in like a poor third. It's actually attached to the Andromeda Galaxy. It's gravitationally bound, so it's maybe through before it's certainly going to end up smashing into that eventually at some point. As far as category, it's a spiral galaxy with no bar, and it's sort of intermediately wound, so it comes out as an SB type in Hubble categorization. It's almost naked eye, if you've got very good eyes and you're very good naked or something like that. First found in 1654 by Giovanni Battista, somebody I've never heard of anyway. So, because it's so big, he actually managed to find it. Got any other pictures of that one?
No, that's the only one we've got. So that was our image with, I think, a 30-second exposure.
You can see some of the bluer outer edges. The star-forming bits of the galaxy are usually in the outer parts, and the core is usually a bit older and a bit deader. So not many stars being formed in the core, and just on the spiral arms. Okay, let's try the next one.
So no one will get this because our exposures weren't long enough to pick it up. If you can see it at all, but this is what it looks like. So we'll default to a Hubble image. No, this is an APOD image, astronomical picture of the day image. So fade that in. Anyone get that?
81?
No.
Is it the sunflower?
No.
Phoenix, is it?
No. Wouldn't necessarily expect you to get it because it's not really what you're used to visually seeing.
Where is it?
So the scope's going to go to it.
So it's now there's rate M109. So one of the almost last ones. I think they were added as late as about 1950s or something like that. Some of the last ones, because they sort of went back through his notes and said, well, he actually found that, so we'll include it in the catalogue, something like that. So it's another spiral, this one with a bar across it. You can see the bar sort of through the centre. Spiral arms. This is a Pierre Méchant, which Barrie talked about. Messier's collaborator, he found quite a lot of these. 1781. And it's the most distant in the Messier catalogue, so we did very well to get that. That's the furthest one away. Can't say very much about it, other than it's a spiral galaxy, very similar, I guess, in features to the Milky Way, as I was saying, as the bar has the spirals, and the other bits and pieces.
To me, it's one of the most amazing that they managed to see. I know it was a bit later, wasn't it? But you wouldn't think they'd be able to see that with the type of scope. So it's quite
I
incredible.
don't know how they stumbled across that. But then I don't know how they found M1 as the first one. That's what we want to find anyway.
That was found by John Bevis, or Bevis, wasn't it, that one?
Oh, was it?
Yeah, I think, yeah.
What kind of telescopes did they use? What kind of telescopes did they use? Was it included?
I think Barrie said that they didn't really know. I don't think it's...
You had 4-inch refractor.
Right. I know it says on the thing a catalogue from using various telescopes, so they were using several.
Maybe his friends he seems to have found all the galaxies. Okay, next one. Anybody?
Bearing in mind what we said about the image scale.
Yeah, very good. So our nearest, in fact, our twin galaxy. So that's the other big one in the area. So usually it's thought of as slightly bigger than the Milky Way. Sometimes it's thought of as slightly less mass than the Milky Way, but it's about the same size. Gravitationally not to the Milky Way. So they're all going to go together. Oh, no. Is it, no, that's a vertical, yeah.
Is it two companion galaxies, both visible in that image?
One of them is, I think the other one should be.
Can't I ever find it?
No, you can't see in that image.
One at the top.
So I should say some image credits to some of our members. So Gareth took a much better image than this, so superimpose that on and it will show you the image scale into that. So that develop it and put that's Gareth's image now overlaid ours. And then this will show you what the question you just asked. It wasn't on. It's not in view.
So Andromeda is obviously one of the most well-studied galaxies because it's so close. There was a big study a few years ago where they actually mapped it in great detail, looked at all sorts of bits and pieces and published lots of papers on it. It has a funny double nucleus, so there's two bits to the very centre of it, but nobody's quite sure why it has two bits. So that's one of the mysteries. And you can pick out individual stars in it. if you want a big enough telescope like Hubble found. Very good. Everybody's seen that. Destined to collide with the Milky Way in about 4.5 billion years. So we'll get a really good view of it then.
C11 might not. There we go. Is it now a decent time to start imaging it? Because I'm starting to see people doing some images on this and putting it on social media. I don't know if it's probably, is it about as high as it gets now? Or? No? Yeah.
I think they've discovered recently that the Milky Way is already warped.
Yeah.
Which is obviously found the gravitational interaction between the two stories.
And by the
Gareth, can you remember how long your exposures were for that a stacked image, obviously?
I normally do 5 minute sorts.
Right.
I can't remember how many there would have been. And normally 2.5, 3 hours, something like that, for 5 minutes sorts.
Right. Yeah. That just gives you a good idea of what getting more data does, doesn't it? Yeah. Did you do that with your SCT?
No, with an ED8.
ED8. To get it all.
Guided, well, almost fully guided.
Yeah.
I ordered the camera on the end of the scope to the angle I want it on, and then just leave it running.
What I don't mind is the conditions. I can't remember that part of Galaxies when I see it at the top. So, although it's sort of the twin of the Milky Way, it isn't really, it's a spiral without a bar across it, and we're fairly sure the Milky Way has a bar across the centre, so it's sort of just an SB, an SBB, which the Milky Way would be, if you're interested. Next one. Correct. M31. M32. Yeah. So this is first the elliptical galaxies. So most of the galaxies out there in the universe are either spiral or elliptical. Depends where you look, which one is more common. Ellipticals tend to be more common in clusters, spirals towards the outskirts of clusters or on their own. They're a lot more boring because they don't really have very much to go on. They're rather diffuse. We call them red and dead because they're red in colour usually because they haven't got any new stars with the glue and they're not making any new stars, so they're kind of just drifting along doing what they've done so far. So they just sort of sit there doing not very much.
Do spiral galaxies go through an evolution where they become elliptical eventually?
They can do if they collide. That's the usual. That's certainly one way of making an elliptical from two spirals. When Andromeda and Milky Way collide, they'll almost certainly come out as an elliptical. You can make ellipticals from scratch, though. It depends how the material falls in initially. It comes in from sort of two angles. They tend to be spirals, and it comes in lots of angles, and it just messes everything up. Elliptical is very messy. All the stars are going around the centre, but not in a coherent way. They all just go around any other way. In spiral galaxy, they all tend to go around in the same direction. So they're sort of like horses on a merry-go-round or something like that. It's that sort of thing, whereas elliptical, every star itself. Some of that happens a bit in spirals, but by and large, everybody follows the rules of the road. So this one is actually a dwarf elliptical, and there's a satellite of Andromeda, and it actually has a supermassive black hole, which I didn't know. So it has a very large black hole right in the middle, which is kind of unusual for that. I've got anything else to say about it.
Is its position going to move?
Yeah, it's gravitation down to Andromeda, so Andromeda will almost certainly eventually devour it. They generally only last for a few billion years. After a billion years, they're gone. Very ephemeral. Same with the Magellanic clouds around the Milky Way. They're doomed. But couple of billion years and they'll be gone.
Well, Magellan never got anything wrong, so.
Next one.
Any guesses?
51.
There we go.
51.
Yeah.
51. Yeah, very good. Another spiral.
Asterism.
Yeah, Whirlpool Galaxy, which, yes, we say Lord Ross sketch in Ireland. Yeah, this is another Pierre Méchain discovery in 1773, and it's actually, anyway, at least Wikipedia says this is M51A, and M51B is the companion galaxy that is housing it. So a lot of what we do at Nottingham is try and work out how galaxies evolve and what kills them, basically. So the spiral the elliptical galaxies are basically killed; they no longer make new stars, and there's various mechanisms that are proposed for it, either stripping gas out. They've got the jellyfish galaxies, they're called. Or there's harassment, there's strangulation, there's about 6 different strategies. Anyway, this is harassment. This is being harassed by another galaxy. So eventually that may strip gas from the galaxy, and that gas is what makes new stars. So if they haven't got any gas, or the gas gets too hot, then they can't make any new stars and they kind of shut down. And they either go elliptical if they're being disturbed enough, or they go to lenticulars, which is the other type that is much less common. I think that's all I've got about that one.
Cool. Yeah. Again, this is a 30-second exposure, so let's have a look what a longer set of subs does to that. So, image credit for Graham Winstanley for this image. So I'll fade that one into this one of Graham's. There we go. Very nice.
I think they found an exoplanet in this galaxy, which is very off the scale. Somebody's proposed one anyway. I think it's around the pulsar or something weird. So, I think that's what I'm trying to do. Okay. Next one is.
So another faint one for a short exposure. So we might test everyone a bit more on their galaxy knowledge.
Really a spiral.
Any guesses? 81. Yeah.
I have to say, I wouldn't guess this one.
So again,
astronomers pride themselves on not knowing where anything is in the sky, or what it's called.
so I'll fade in a Hubble image of that into roughly the right place. It's a Hubble version. Make it a bit bigger.
And this is a classic grand design spiral. You can see the lovely blue outer arms where star formation is happening, and the rather reddish centre where star formation isn't happening. So they're making lots and lots of stars in those spiral arms, of all colours, red, yellow and blue, but because blue stars are very, very bright, very, very hot, they outshine everything else. So that's why it kind of looks blue. And blue stars don't last very long, so they quickly shut off. And that's why you're left with the red stuff for either the cores of these galaxies or the elliptical galaxies.
Yeah, again, that's quite low down at the moment, so relatively that's the position of the scope on that one. So no one will get this one, so quite faint. There we go.
Sunspire Galaxy. Spiral Galaxy. Yet another spiral galaxy.
We'll call on the Hubble image, and that's Hubble image.
I think that's probably a multi-spectrum one because it's some extra bits on that. So again, the blue outside, the red inside.
It's a bit dusty.
Bit dusty at the bottom, yes, lots of dust.
We lost that one into the murk as well.
Yeah.
It's actually above the horizon at the moment to go to.
Right, next one.
Yeah, quite tricky. So, Hubble image. Very small, so I'll blow that one up.
Really $8.
Is it the Spindle Galaxy in Draco?
Yeah,
I've only got the number down here.
there you go. Spindle Galaxy, yeah. Very good. You're winning.
That is in my view, the correct version of M102. M102
Yes.
is not a duplicate of 101.
Yeah.
Right, yes. There's some controversy about this, because I think you could have M101. This is a lenticular galaxy, Aegon, so you can think of lenticular galaxies as spiral galaxies that have lost their star formation ability. So they're spiral galaxies without any spirals in them. So the stars are all going around in a thin disk, but for some reason they no longer produce much. So that does look quite good. You can find red spiral galaxies and you can find blue ellipticals. They're just very much not the norm.
So are they honest?
Well, they're almost so yeah, lenticular galaxies much less common because they're kind of retired spiral galaxies. But something usually has to happen to them to get rid of the star formation. Got any other interesting?
Yeah, so yeah, as Sam said, M102 is really the main error in the Messier catalogue. So it was discovered by Pierre Michan, and he admitted that it was a mistake and it was a duplicate of M101. Something to do with it was added to the catalogue at the last minute, so there wasn't time before publication to check the positions. It was the message to check the positions that it was given by Michan, so that's why it actually is the error. So this was used, so it's NGC 5866, and it was suggested as a suitable object to fill in the Messier catalogue blank, closely matching the object's description by Michan and the object's position that was listed by Messier in his notes. So that's why this was inserted, essentially, to keep the catalogue complete.
Is there a schism between American and European astronomers over whether 1 and 2 is correctly in the catalogue? Because as far as I know, the Americans don't accept it.
Right. Yeah.
But the European version is to accept this as the part of the Messier catalogue.
Yeah. I'm not sure.
Most professional astronomers don't really care. It's like, you know, what can I write a paper about? It's interesting here, and the main of it is more science.
I was going to ask the question, from the original documents put there, what coordinate system was he using at the time?
RA and deck, yeah. RA and deck. Yeah.
Because one of them is, which one it is? One of them is out by 15 degrees or something. They hit the wrong line.
Yeah. I think sometimes he did positions from a known galaxy and the position from that point to the object that discovered as well, which I think is one of the reasons why one of them was wrong, because he went the wrong way and got the negative sign the wrong way or something like that.
He wasn't as good as he thought. So he wasn't really in it for them. He was listing lists of awkward things that got in his way, basically. He got in his way of finding connects. Okay, last one of my set.
Okay.
To Cigar Galaxy.
You don't even need the better image, that's good.
Yeah.
So the Hubble image, blow it up a bit bigger.
So this is classified as irregular. So it's, you can sort of see the original is up and down, but the big outflows in it, which are particularly obvious in infrared. And it's also a classic starburst galaxy, so it's making lots and lots and lots of new stars, maybe 500 a year, something like that. Whereas the Milky Way makes about 1 a year. So it's highly disturbed, and by M81, I think, it's highly disturbed in Paris. Churned it all that gas that was just floating around doing nothing is suddenly collapsing stars and this big burst. I suspect if we come back in about 1 billion years, it will settle down to be a very dull number. But because it's also churning up, we've had at least one supernova in it recently. So because it has this big burst of star formation, the really big stars don't last more than a few million years, so they quickly pop off into supernovas. So it's a good source of supernovas, and that will fade away, and then we'll have to wait a long time for the...
There was a supernova discovered in it a few years ago, visible clearly from Earth. I saw it.
Yeah. Is that the one in UCL?
Yeah.
Discovered by accident. UCL.
So all time question destroyed the next exploding galaxy.
Yeah. Irregular starburst. So irregular was Hubble's category for anything that didn't fit into his category, basically. This is one of the, most of the irregulars tend to be dwarf irregulars or something like that, so they tend to be around the galaxies where the gravity is sort of pulling them apart. So both still large factor element clouds are classified as irregulars, although some people will argue that they can see faint spiral structure or something like that, but they're so harassed by this big Milky Way pulling them around and never get close to settle down. Okay. Any questions? I'm going to leave the stage. Swap with James.
Thanks,
Well,
Julian.
I'll ask you a general question.
Yeah.
How popular, if you like, was comet hunting at that time? Did it turn the catalogue into a bestseller because lots of people use it, or was it a side issue?
I think the catalogue itself is a sort of side issue because you've got big, you've got in the press for discovering new comets and things like that. And nobody was interested in galaxies or anything like that point, they were just fuzzy things in the sky. So because comets have got this sort of mystery about them, I think hasty, sort of comet battle.
Yes, the classical today.
Yeah. So comets were where it was out to perhaps overlap with a bit with astrology and all that. So get your name and papers for the study of comet. Couldn't get your name and papers for the study of the galaxy.
I bet it's as well known now, the NASA catalogue, than it was back then.
Yeah.
I'd imagine. Good. Well, thanks for that. Thanks for doing your own marathon of talks tonight. Your second talk in one evening, which is quite impressive. Okay, so the next sort of category of the catalogue is Planetary Nebula. So Planetary Nebulas are a bit of a misnomer because they're nothing to do with planets. So really it was when they first sort of saw them, I think the first one that they determined as a planetary nebula was the Saturn Nebula, and that sort of reminded them of looking at planets through early telescopes, sort of seeing the general sphere. So that is how the term planetary nebula came about. So that was, I think, William Herschel sort of came up with the term planetary nebula. So the nebula basically is the result of an old star, so like similar to what our sun will do. So it goes to sort of its red giant phase, gets much bigger, and it starts losing its atmosphere or gases coming out of it. And once it's shed enough of those, it essentially collapses down, becomes a white dwarf, and that the energy release and the plasma that comes out when that happens essentially thrusts out more gases and plasma at a much faster speed than the original gases of the red giant phase, and essentially those hit those earlier gases, and that's what creates these amazing sort of structures that we see in the planetary nebula.
That's essentially what they are and how they're created. So let's have a look at a couple of those. I can't remember exactly how many planetary nebulas there are in the catalogue. So this one, probably the most well-known, so
27.
everyone's going to get that. Yeah, M27, that's basically a bigger blown-up image of it. I think that's Gareth's, your image?
Looks like it.
Yeah, so that's Gareth's image of it. Again, much longer, or more subs in that, but that's what you can get. I certainly think visually through the telescope is probably one of the more impressive of the Messier objects to look at. I don't know if anyone agrees or disagrees. Our visual observers.
It comes up well in an O3 filter.
Yeah. And what sort of scope are you using now?
C11.
C11 as well, yeah. It's a very, very nice image. So one to look through the C14 up at the observatory when you get the chance. It's definitely visually one of the best, I think.
Is the scale there? Is that a C11?
Yes, that is the C11, yeah. So all the first images, that image is taken through that scope. That's just the single exposure. It's quite a bright object, so a very short sub of 30 seconds pulls out that level of detail, which isn't bad for a single exposure, with no tracking or anything on it. Yes, the Dumbbell Nebula was the first planetary nebula to be discovered by Messier, and the actual name was given to it. Well, it's a popular name. The Dumbbell Nebula was given by John Herschel, and it says online that estimates of its age is about 9,000 years old. Relatively young object, as many of them are.
Is that something that's not responsible for the gas that's surrounding the forms of nebula? The sign?
Could be, I'm not sure off the top of my head, to be honest. Right, next one. Again, a popular observer target, this one. Didn't come out as well at this image scale as I thought, if I'm honest.
57.
Yeah. Yeah, and there's a bit of smearing, I think, in that. I don't quite know what happened there. Perhaps we did a too long exposure without guiding it on that one. Wasn't the nicest. So a better image for it. I don't know when you took this, but this was taken by James through his C11. That's quite fantastic, isn't it? Not far off Hubble stuff there. It's good. So that was taken by James with C11. 30-second exposures, 2-second intervals between each sub, and a total of 271 exposures in that image. That's 135 minutes worth of data to produce that image. So that's the difference between 30 seconds, 135 minutes. So again, a good example of what more data does for you. Sorry? Oh no, I'm sorry, I forgot. I put the scope as in. Can't multitask. So yeah, so that will go to the Ring Nebula in Lyra at the moment, hopefully. So yes, distance across is, I think it's quite difficult. Julian may know more. It's quite difficult to estimate the distances of the Planetary Nebula. So I've read. So that's 2,300 light years across. So it says the inner ring. Sorry, the distance away from us, 2,000. Go mad. Yeah, that is a bit big. Yeah, so 2,300 light years away from us. So the sort of image or the scale of it. So from the inner ring, so sort of from there to there, is 0.9 light years across, and then the outer is about 2.5. So yeah, so I'm just reading some sort of observing tips. Again, interesting to see if the observers agree or not. So it says a magnification of about times 100 is really needed to bring out the Ring Nebula. So I don't know if anyone.
We had a look at it last observer session.
Yeah.
Observatory. I think we used it.
We used that.
Right. And it says to get the two central stars there and there, you need sort of magnification of 500, and also it says good seeing to see that through a C14. So again, don't know if people can you pick out the central stars? Can you see 11, Sam?
No, I can't.
No, quite difficult because that's it's fantastic. But, quite difficult to pick out the central stars.
I think the ring nebula is possibly the most satisfying Messier object to observe.
Yeah.
Through a telescope.
Get the colour as well, can't you? Just about.
Yeah.
I can,
It looks like a little smoke ring in the sky.
yeah.
And the C14 is very obvious, the outer ring against the inner ring, you can see the velocity in the centre,
Yeah.
and then the denser material on the outer side.
Yeah. Do you get much hint of colour in the C14?
I didn't think so. It seemed great to me, but
I wonder if that's the part that perhaps seeing is quite important for. I don't know. I've definitely had colour in my C11 when I
it
looked.
was getting quite hazy when we
Yeah.
looked at it, so that was attractive from the contrast.
Yeah. Right, let's spin on. Last one from me, I think. So, slightly disappointing image, I thought, but perhaps not too bad. Anyone know what that one is? Yep, very good. Again, that was quite a short exposure. I think that was less than 30 seconds. So I put the scope on that one. So M97, Owl Nebula. A better image I managed to find for you there. Not sure where that image was taken from, actually. I'm not putting it down on here. There's a major, sometimes known as the North Hemisphere Owl Nebula, so the Southern Hemisphere Owl Nebula, which is similar, quite similar. 2 light years across, which says 2,000 times the diameter of Neptune's orbit. It's got 0.5 solar masses. And again, I think this is one that they've said the distance estimates away are very uncertain. That's a huge range, actually, when I was trying to find it out in different sources. So 3,300 light years away. It says you need an 8-inch scope to see the faint central star. I'm not sure about that one. Not quite sure about that. But yeah, it's a slightly older object than the Ring Nebula and the Dumbbell Nebula, which is apparently because of the sort of more advanced state of the outer shell. So that perhaps something to do with its age as well. So those were the 3 planetary nebulas that we managed to image. I was just spinning that round to show you some other stuff there's quite a lot going off in that image. So it's not very far away from so that's a Cigar Galaxy, so going off around there. It's quite interesting, I always think, when you see some of these images that are very focused in, then see what else is actually not that far away. Right, so I don't know. One I stole offline. I'm not sure. Cool, so let's carry on because we've still got quite a few more to get through now. So James is going to do the next 2 categories, the globular and open clusters.
Do I need to change?
Possibly, yeah.
Right. So globulars and open. So obviously globulars are these globules, clumps of stars, and open clusters are collections of stars which are associated with each other but in a more open pattern. And I found this nice
slide online. So globulars and groups of tens of thousands to hundreds of thousands of stars, very symmetrical in a ball, frequently contain bright red giants, located in the halo or bulge of the galaxy, composed of old stars, and they're no longer forming in the Milky Way. And then on the other side we've got open star clusters, so groups of hundreds of stars, irregularly shaped, have got bright blue stars, so young stars, located in the arms of the Milky Way and other spirals. And as we said, young stars, and these are continuing to form. And this is a what's the diagram called? Venn diagram. And then there's a central section where they've got things in common. So they're all groups of stars held by mutual gravitational attraction. All of the stars are roughly of the same age and are formed from the same cloud of dust. They're roughly the same distance from Earth, so that there's not a it's not an apparent feature. They are actually close to one another, and they all orbit the centre of the appropriate galaxy. So here we've got a spiral galaxy looking face on, and the centre of the galaxy is here and spiral arms. And if this is the Milky Way, then we're out here, wrong way. And then if we look at it from the side, so we're now looking edge on, these arms are quite thin and they're here, and we've got the central bulge of the galaxy, and then we've also got this halo of other matter which is gravitationally spinning around the centre of the galaxy. So when it talks about the open clusters are in the spiral arms, and the globular clusters are around the bulge and the halo. So here's an artist's impression of the Milky Way, and again you can see the central galactic bulge and then this halo of other matter and the spiral arms edge on. So this is looking at the Milky Way edge on, so the arms are out to the side and the galactic bulge, and then these dots mark where the globular clusters around the Milky Way are. What are these two things? Yeah, the large and the small Magellanic Cloud. And here's a showing the array and deck of the Milky Way. So this is the Milky Way, the arms. The galactic centres over here. The green dots are globular clusters, and you can see they're mostly associated around the central galactic bulge, but there's also some others elsewhere, and there's even some out here with the large and small Magellanic Cloud. And then the open clusters, as we've seen in the definition already, are following really the plane of the galaxy. And then we've got galaxies, which Julian's already talked about. The distribution on this map is influenced for galaxies, certainly, because we can't see through the galactic bulge. It's just too dense. So this is the first globular cluster we took a picture of. Again, it's all under 1 minute. This is M2, and if we zoom in a bit more, you can see that these stars are red, so that fits with the definition. They're old structures, and this one was discovered in 1746, not by Messier. He didn't discover them all. Other people had recorded several of them before him, but he just put them in his catalogue because they were troublesome for him. So here's a better picture of M2, and again you can see there's lots of bright orangey red stars, and a very dense centre. And I've written down on a bit of paper at work today the numbers of stars. So how many stars do you think are in there?
20,000.
It's not a bad guess. 150,000. That's what Wikipedia says.
Are they all the same kind of stars? Same age?
Julian? So they're all the same, roughly the same kind of age, yes. As to are they the same classification?
Not quite. The latest view is that if you look in detail, there's like a red population and a slightly blue population. It's like a binary distribution. So I don't think anybody's quite sure why. But there's lots of papers saying, yeah, it's clearly binary.
Presumably, the size and when they form would affect their lines.
Yes, and they're really quite close together as well. Four light years between stars where we are, but it's down to half a light year, I think, in some of these cases. So they can actually collide with each other and influence each other and dump stuff on each other and generally behave like bad news.
So here's the Dumbbell Nebula again. So looking through the same eyepiece, which of these three dumbbells do you think is the size, the appropriate size for the size of M2? Small, medium or large?
Well, it depends how much light we gather.
It's large. So for the same eyepiece, M2 would look that big, and then the dumbbell would look a very similar size, although the dumbbell is slightly bigger. But in reality, the M2 cluster is 150 light years across, roughly. These numbers are all sort of kind of slightly arbitrary, and it's 55,000 light years away, whereas the dumbbell is much smaller, but much closer. And as Richard alluded, the distance to planetary nebulas is a bit nebulous in itself, because they find it very difficult to get accurate measurements of their distance. Why is that, Julian?
I guess you can't really do parallax on them quite so well. And a lot of the distances you can work out if you know what the star is, you know how luminous it is. So you can, whereas this is like how luminous is a globular cluster that nobody knows.
So sounds something Guy might say.
I was thinking that. I don't know. We can't do parallax.
If you can detect this central black hole.
Oh yeah.
So this is M2 as seen through the C14 at the observatory with a 31mm Nagler eyepiece, and you can see it could take a bit more magnification, where you start to see more stars. You start to resolve more stars. But as recently we looked at a globular cluster, didn't we, at the observatory?
Yeah.
And what was it like?
But on my magnification, the darkness of the
So this is the next globular cluster we imaged, M13 in Hercules. This is probably the premier globular cluster, and if we do comparable images of M13 and M2 we've just looked at, you can see it's a much bigger entity and it's brighter. It was discovered by Halley, or how do you pronounce it? Who knows? 1714, and again you can see lots of red stars because it's an old structure. And if we go back to the observatory scope with a 17mm eyepiece, you can see the difference between M2 and M13. M13, you're really getting engrossed into that cluster compared to M2 because it's much bigger.
Well, the first one's in the southern hemisphere, isn't it?
Yeah, what's it called?
The Cassiopeia A.
Yeah, Amiga Centauri. Yeah.
Not sure whether that's a globular cluster.
Oh, it looks nice.
Could be an ultra compact dwarf galaxy. People argue.
Sam, were you going to ask something?
Yeah, I was just saying, most people would say the premier globular cluster is Omega Centauri.
Yeah, sorry, I meant in the northern hemisphere.
Yeah.
Yeah.
You can see Omega Centauri from southern Portugal, so it might count as northern hemisphere
Right.
in one sense.
Yeah. So here's the next globular cluster we imaged. M56, again back in Lyra, and we can compare that again to M13. So you can look, there's a big difference in the number of background stars as well here. So this is another reason, I suspect, why M13 stands out so nicely, because it is brighter, but it's framed better. There's less clutter. Well, it's not clutter. Background stars. Or they could be foreground stars. This was discovered by Messier in 1779, and this is comparing again the 17mm eyepiece at the observatory, 56 versus M2, and they're probably reasonably comparable, but again M56 is in a very busy part of the sky, so there's lots of stars. And if we look, where is that in the sky? So here's looking south, and it's the summer triangle, so what are the stars? Yeah, so that's the summer triangle, and the two stars here are the ones which will, so here's Vega, Deneb would be up there, and Altair would be down there, and between these two stars is M57, which we've already seen. If you draw a line down, probably 1.5 times the distance, you get to M56. So we've briefly had a look at M2, M13 and M56 for the globular clusters. Okay, Sam?
Sorry, do M13 again. Have you got that right?
Possibly not.
It's not minus 30 degrees.
Open the book.
Well, M13 is well up north.
I knew I shouldn't have put these arrows on. Someone get the declination of M13.
It's plus 36 degrees.
All right.
So the scale is pointing at it.
And what's its RA?
About 16.5 hours.
So it's one of those three.
Yeah.
Sorry, Sam.
Not making mistake here.
I know. So we've seen those three, and now we're going to whip to the open clusters. I'm scared to put these arrows up. I did those in theatre today, Sam.
Sorry?
I did them in theatre today. I was trying to keep the patient alive at the same time.
When the clusters were open.
Get your priorities right, James.
So, open clusters. M11, the wild duck cluster. What do you all think about this as an open cluster? Yeah. So that's what I thought. I thought, blimey, Sam's going to ask me, surely this is a globular cluster. But it's not, it's an open cluster. How many stars do you think are in this cluster? 2,900. I don't know, do they have PhD students to count them? This was discovered in 1681, and this isn't one of Lord Ross's drawings, although it's not dissimilar. This is off the Cloudy Nights Forum, and you can see that it's got this sort of V shape, and this is where the name, the wild duck clusters, come from. It looks like a formation of geese flying in their V pattern in the sky. So if we stick the wild duck cluster on the C14 with that 17mm eyepiece, it's just a bit of a mess, and you don't get to appreciate the beauty of it. So we're going to change to the other scope at the observatory, which is the ED80, but keep the same eyepiece on, and you can see that there's that sort of central mass of stars, and the cluster extends a bit more. It doesn't show that V pattern, but actually the V pattern, you can see that when you look at it through a lower magnification eyepiece. And get, let me go back. What, there? Yeah. Yeah. I mean, in an eyepiece, you don't, low power, you don't differentiate all these stars so easily. So it does look more like that V. But yeah, you're right. So that's going to be a theme now. So the C14 is good for those nice compact, small entities like the Planetary Nebula, the Globular clusters. But if you want to appreciate something like the open clusters, you need a shorter focal length telescope or pair of binoculars. So the next one is M34 in Perseus. This was discovered in 1764, and for anyone who knows M34, they'll realise that it's not in the image. It's down there somewhere. Richard failed. So again, I spent about an hour today trying to run this image through various software to plate solve and figure out where M34 was. Yeah. So this is M34. Again, we've got nice blue young stars, which fits with that definition of the open cluster being young, and then there's our image, and if we superimpose that image, you can see where we missed it, but we tried. Next one, M39 in Cygnus. Apparently Aristotle noted it in 325 BC. Who knows? There's a nicer image of it, which showing the blue stars, and I've rotated it because it's got this nice sort of, you're looking at this because you've got a triangle of stars and a double in the centre. In the centre. Again, you've got Skywatcher and the 17mm eyepiece, and you can make out the triangle and then the double in the centre of that. And then the last one, because I can hear people yawning, you'll all be pleased to know, is M45 the Pleiades or the Seven Sisters. In Taurus, again you can see hints of blue. Now, this is not the right scope to image the Pleiades because they're bigger than the field of view of the setup. It's been known since antiquity, and reading today, the Seven Sisters could relate to 7 doves that took ambrosia to the baby Zeus, maybe. Yeah, hope it wasn't lumpy. And Gareth comes in again, good old Gareth. Another one of his images is a nicer image of the Seven Sisters, the stars in the background, illuminating this nebulosity. And again, we need to zoom out a bit to get all 7 in. And how many stars do you think are in M45?
Well, there are 7 main ones, but it's more like 40.
1,000, yeah. And it says many aren't visible. I don't know what that means. Yeah, maybe that PhD student went off the rails. So here we've got...
I got the diffraction spikes on my image.
Yes. How did you do that with the refractor?
Bits of string.
Right.
On the G shield, so I put one string, one there, 90 degrees.
Ah.
I thought it would look nicer with diffraction spikes. I think I read about it in Sky High magazine.
Yeah.
So it's cheating.
Well done. So here's a view through the ED80, again with the 17mm eyepiece, and you can see the whole of the, most of the open cluster. And the 2 books I used were these 2, which I brought along. I think that's it. I'm not going to ask you how many stars in those books.
Say the Nottingham University done most of the Messier objects in deep sky images. Deep sky videos, yeah. I think they've done maybe 100 of them now. They all fight when we're given another globular cluster to talk about. I know everybody said everything there is to say about globular clusters and spiral galaxies.
Great, thanks James. See what I mean earlier, I said you'd be glad that we aren't doing all of them tonight, otherwise we'd be here for ages. So that essentially completes our Messier marathon that we did. So it was roughly just shy of 2 hours of obviously positioning the scope, sorting the camera out and everything. So that's how long it took essentially. So if you're doing them all, you're there for a while. So that's essentially our Messier catalogue that we've done so far. So it'd be quite nice to have a stab at filling that in over the coming years. See if we can get them all. It should be quite good. Quite a fun thing to do. I've never done it visually. I don't know if people find it a worthwhile exercise visually trying to do this, but it's something definitely to try out. Very quickly for completeness, really just to pick up the few of the types, because we've split these up into types, the ones we've not covered. So most of these, they're just singular objects of the type. So most people probably know what that is, so I won't bother asking. It's M1, so that's a supernova remnant as its object type in the Messier catalogue, and sits alone in that sense. So that was discovered by John Bevis or Bevis in 1731.
Ancient Chinese one before that.
Yeah, possibly. Yeah. So obviously it was a supernova remnant which went off in 1054, and I think quite a lot of different places have
recorded the guest by the Chinese.
Yeah, recorded that.
Specified it was.
Yeah, so it's 6 light years wide. Is it I'm sure I read somewhere it's the newest object in the Messier. as you'd expect, I suppose.
The other one is the hardest to find.
Yeah, and so that was behind a mountain if it was in Wales, but there we go. So yeah, that's that one. So again, just to finish off, M40, Winneck, is that how you pronounce it? Winneck 4, that's how you pronounce it. So this is a double star. So I think it was possibly put in purely slightly through confusion, thinking there was some nebulosity there when there isn't. And it's described as one of the few real mistakes in the Messier catalogue. So yeah, it shouldn't really have been in there, as it's not a nebula.
I think that was the one by American most painful.
Right. Yeah.
Put it there, someone's nebulous in the poor repository tracker he was using.
Quite possibly, yeah. But yeah.
Possibly Messier's biggest mistake was not including the double cluster.
Yeah.
It's such an obvious.
And such a nice thing to look at.
Everybody must have missed that.
Yeah.
Was Messier from a fairly well-to-do background or not?
I think so, yeah. Yeah.
Well, it was interesting then, he kept his head where the Messier didn't.
Yeah.
What, did he have any interaction during the French Revolution?
Some of his big mates did lose their heads, so yeah. No, I think that curtailed his astronomy in later life, I think.
He said, well, I've got the legend and
Make it difficult without a head.
Yeah, so it's classed as an optical double star. There's no interaction, gravitational interaction. I think that guy has shown that quite recently. So there's no interaction with that. So that, again, one of the ones that sits on its own classification within the Messier catalogue. The Triffid Nebula, I don't know anything about diffuse nebula. Does anyone else? Not one I've managed to have a look at anything about. So I'll read what... Yeah, perhaps we should. It says it's an unusual combination of open cluster of stars and an emission nebula and a reflection nebula. So there we go, it's got everything. Yeah. And then the very last collection, Asterism. Again, physically unconnected stars that appear close together when viewed from Earth. It says that this group found its way into the Messier catalogue because it determined its position at the same time as measuring M73, which is 1.5 degrees to the west. And it's been included because at first glance he thought it had some nebulous or nebulosity in it. Yeah, and he says, although it is clear from the description that this group was what Messier had observed and measured, some versions of the Messier catalogue actually omit it as an obscure object. However, John Herschel included it in his general catalogue. So it's got NGC number 6994. So that's essentially just to complete all the different types to go through today. So that essentially is our Messier marathon imaged in less than a minute. So I hope you found that useful. Thanks very much for... Polmaster. Yeah, so huge thanks to Julian and James for preparing all of that, and also to Barrie for doing his little history on Messier the man. So it was really good. So hopefully see you at the next meeting in Gotham, which is Steve Barrett's, isn't it, I think?
Steve Barrie.
Good.
It looks like Chris has turned up with cake as well.
Oh.